Hello, my name is Franklin, and today I want to investigate how four different algorithms compare in terms of runtime. The algorithms in question are selection sort, insertion sort, merge sort, and quick sort. I will not go into the details of getting the asymptotic runtime of each of these algorithms. However, I just want to point out that in the worst case, selection, insertion, and quick sort have a runtime of big O of n squared, while merge sort has a runtime of big O of n log n. I will stay away from the mathematics of determining the asymptotic runtimes of these algorithms. There are a lot of resources on the web that explain how to obtain these asymptotic runtimes. In this video, I just want to focus on how fast each algorithm runs on arrays of random sizes. To do that, I will simply calculate how long each algorithm runs on the same array containing the same inputs. I will save the runtimes in seconds it takes for each algorithm to run in a file and graph the results. Before we run the code, let's go through the code and see what each algorithm does. Here is the selection sort algorithm. Very short and simple. It selects the smallest or largest value at each run and places the value in its right position. Then it repeats the process over and over for every value in the array. Here is the insertion sort algorithm. It uses the principle that one half of the array is sorted and the other half is not sorted. It inserts each value of the array in its right position. So it basically picks values from the half that is not sorted and places the value in the half of the array that is sorted. At the beginning, the algorithm assumes that the first element of the array is in the sorted half of the array, and everything on the right of the first value is in the half of the array that is not sorted. Here is the merge sort algorithm. It uses the principle of divide and conquer to recursively divide the array into two halves and sort each half. The array will be subdivided recursively into two until there are n arrays of size 1. An array of size 1 is sorted. The algorithm then merges the sorted arrays of size 1 from bottom to top until the final array is sorted. So sorted arrays of size 1 will be merged to become sorted arrays of size 2. Then these will be merged to become sorted arrays of size 4, and so on and so forth from bottom to top. The final result will be a sorted array. Here is the quick sort algorithm. Quick sort uses a divide and conquer approach like the merge sort. It partitions the array into two partitions, separated by a pivot value in the middle. This pivot value is chosen at the beginning of the algorithm. For simplicity, the pivot in this algorithm will be the last element of the array. The algorithm then runs by placing every value less than the pivot value to the left of the pivot, and every value greater than the pivot value to the right of the pivot. So at the end of each run, the pivot chosen will find itself in the right position. The algorithm then recursively runs on both partitions, repeating the same process over and over. Again, there are a lot of resources on the web that explains the details of these algorithms thoroughly. I wrote the code for these four algorithms in C. I chose to write them in C because the C programming language is very fast, despite having a lot of flaws and drawbacks. I believe that learning to write good code in C will give me the skills of writing better code in other programming languages like Python or Rust or Ruby. These do not have the drawbacks and flaws that C has. By writing in C, I believe I'm developing better coding habits. Here is the code for the main function. Here I start by generating random numbers between 1 and 100. Then I place these numbers in an array of arbitrary size. Then I duplicate the array so that I can run all four algorithms on the exact same data. For each algorithm, I measure how much processor time it takes for it to run on the array I generated. I save these runtimes in the CSV file. Then I will visualize the results on a chart and visually compare the results. For each algorithm, I measure how much processor time it takes for it to run on the array generated. I save the runtimes in a CSV file. Then I will visualize the result on the chart by visually comparing the results. Let's run the algorithm and see the results. The code runs and takes a very long time. So I will fast forward to the end of when the code has finished running. Here are the results. I will upload the CSV file to the Google Sheets and create a chart of our results. Here is the chart. We can see the graph of the runtime versus the sizes. From this graph, we can conclude that the selection and insertion sorts are slower than merge and quicksort. Now, I did mention at the beginning of this video that quicksort in the worst case has a quadratic runtime of big O of n squared. Now, in real life, the worst case of quicksort almost never happens. The average case for quicksort is as fast as the worst case for merge sort. Here is the end of this video. Thank you for watching. Please subscribe to my YouTube channel to stay alert of any new videos I might publish. Also, please do not forget to place your comments in the comment section. Okay, see you at the top.